Okay everyone, so we're going to have a little look at some simultaneous equations, and before we start looking at them in a more algebraic form, we're going to look at a couple of worded problems. So if we look at this thing on the screen here, we've got 2 dogs and 1 cat weigh 70 kilograms, and 2 dogs and 2 cats weigh 86 kilograms. And what is the weight of the dog and the cat? Now some of you might be able to deduce what the weight of the cat is just by looking at the picture. And that's what we're going to use to help us do our algebraic simultaneous equations. We're going to use pictures to help us solve the problem. And rather than drawing animals, we're going to use the bar model. So before we start, we're going to actually form the 2 equations that we've got here. And before we can do that, we have to define some things. So I'm going to use the letter D to be the weight of a dog. And I'm going to use the letter C to be the weight of a cat. And if we look at the first situation, we've got 2 dogs, the weight of 2 dogs plus the weight of 1 cat is 70 kilograms. So that gives us the equation 2D plus C equals 70. And then if we look at the second one, we've got 2 dogs, so the weight of 2 dogs plus 2 cats, so we've got 2D plus 2C equals 86. And these are our 2 what we call simultaneous equations. And so I'm going to write these under here. So 2D plus C equals 70 and 2D plus 2C equals 86. Now rather than actually in a problem drawing things, we're just going to use our bar model to help us out. So if I drew that, I'd say the weight of 2 dogs plus a cat is a total of 70 kilograms, so I'm just going to draw it as a bar. And for the second situation, I've got 2 dogs, so they go identically underneath the 2 dogs from the first problem, and 1 cat, but then in the second equation I've got 2 cats, and that all equals 86 kilograms. Now because this is exactly the same as this, I can quite quickly see that the length or the weight of 1 cat has to be the difference between my 70 and my 86 kilograms. So the weight of 1 cat is going to be 16 kilograms because that's the difference. And the second situation had 1 extra cat. And then if I use that, I can say, right, so if that's 16 kilograms there in that the weight of that cat, I can see that the 2 dogs here must weigh 70 take away 16. So my 2 dogs must weigh 54 kilograms. And so if these 2 dogs here weigh 54 kilograms, that means that 1 dog must weigh 27 kilograms. And using my bar models, I've worked out what the weight of the cat and the dog is. So the cat is 16, the dog is 27. Right, let's have a look at another problem. So here we've got the cost of apples and pears. So again, I always like to define what my letters represent first. So A is going to be the cost of the apple, and P is going to be the cost of the pear. And if I create my 2 equations, for the first situation, I've got an apple plus a pear costs 40 pence. So I've got A plus P equals 40. And when I look at the second situation, I've got A plus 3P equals 84 pence because I've got an apple plus the cost of 3 pears. And again, I'm going to use my bar modelling now. So I've got my apple plus my pear. Now they cost 40 pence. And then underneath I've got an apple plus a pear plus another pear and plus another pear, and they all make 84 pence. Now this is slightly different than the previous example because I can again work out the difference, because again if I look, this picture is identical to the picture underneath, so this lines up here. So I can say the difference between the 2 is 44 pence, but that's the cost of my 2 extra pairs. So my 2 pairs cost 44 pence, which means one of the pairs must cost 22 pence. And it is a bit awkward using p, because p for pence and p for the variable can get a bit confusing, which is why I've put pence on the end there. So going back to my picture, I've worked out that a pear costs 22 pence. So that means my apple is simply 40 take away 22. So the cost of my apple is 18 pence. Right, I've got, I think, 2 or 3 more examples. So this one hasn't given us any pictures this time. It's just give a worded question. But again, the first thing I'm going to do is define what my letters are going to represent. And in this case, I'm going to use W for the cost of a bottle of water. And I'm going to use C for the cost of a can of Coke. Okay. So with my first situation, I've got 1W plus 3 Cokes equals £2.30. And with the second situation, I've got 3 W's, 3 waters, plus 3 Cokes equals £3.90. Right, so I'm just going to look at these two equations. I'm going to draw the picture. Now, to begin with, you might naturally do this. You might go, well, I'll put a water and I'll do 3 Cokes like that, and that costs £2.30. And then I'll do my 3 waters and my 3 Cokes on the end, and that costs £3.90. But if we look here, we've got a bit of a problem if we draw it like this, because I haven't got a situation where anything lines up, so I can't scribble anything out. So this wasn't the best way to draw it. What you've always got to have to make simultaneous equations work is you've always got to have the same number of one of your variables. And we do. We have 3 Cokes in both of these situations. But that means I should draw the 3 Cokes first. So I would actually draw my 3 Cokes plus my water is £2.30 for the first situation. And then I've got my 3 Cokes plus my 3 waters in the second situation, which is £3.90. And now I can see that we have got a situation where all of this is the same as all of this. So the difference between the two is £1.60. So that means my 2 waters cost £1.60. So a water is 80 pence. And if I then put my 80 pence in that top bar, I can see my 3 Cokes are going to be £2.30 take away 80 pence. So my 3 Cokes are going to be £1.50. So my Coke is going to be 50 pence. Okay. Right. Now, these next two are a little bit different because they have a bit of a problem with these next two. But we'll start off exactly the same way as we always do. I'm going to define what my letters stand for. And C is going to be the cost of a coffee. And I'm going to use P to be the cost of the apple pie. And so for my first equation, I've got 2C plus 2P, because I've got 2 coffees and 2 apple pies, is £2.20. And I've got 3 coffees and 1 pie equals £1.70. Now, if I were to draw these, the problem is I don't have the same number of coffees or the same number of apple pies. And so no matter how I draw this, I could draw 2 C's and 2 pies, just make my pies smaller just to emphasize something. And then I've got my 3 C's and my 1 pie. And again, nothing is lining up. And even if I do the pies first and then the coffees, it's not going to line up. So I have to think a bit more clever about this one. And before we go on to what we do, here's an idea for you. if I had 3 coffees and 1 pie, and that cost me £1.70, how much would 6 coffees and 2 pies cost? Well, if I think about this, I've got 3 coffees and a pie, and another 3 coffees and another pie to make 6 coffees and a pie. So that is going to cost me £3.40 because I've doubled the number of coffees, I've doubled the number of pies, so that means I'm going to double the cost. And that's what we have to do here. We have to try and make the number of pies or the number of coffees the same. And so what I actually think is I'm going to double everything in this equation. So I'm going to say 6 coffees and 2 pies are going to cost me £3.40. And now I'm not going to use that equation anymore because I've got a situation where I can draw a picture that's going to line up, because in both of these two equations now I've got 2 pieces of apple pie. So when I draw this picture, I'm going to draw the pie first. So for the first one, I'm going to have 2 pieces of pie and then 2 coffees, and all of that's going to be £2.20. And then for the second equation, again, I'm going to have 2 pieces of pie. I'm going to have 2 coffees, but actually in this one I need 6 coffees, so I'm going to extend it. Oops. And I'm going to have 6 coffees. So I've got 2 pies and 6 coffees, and all of that is going to be £3.40. And now I have a situation where I've got 2 pies, 2 coffees, 2 pies, 2 coffees. So I can see that the extra bit is my 4 coffees. And so my 4 coffees are the difference between my £3.40 and my £2.20. So that is going to be £1.20. So my 4 coffees equal £1.20. So that means a coffee is going to be 30 pence. Let's assume this is a charity fair because that is very cheap for a coffee. And now go back to one of our diagrams, and I always go to the smallest. So if that's 30 pence and that's 30 pence, I can say my 2 pies are going to be £2.20. Take away 60 pence. So my 2 pies is going to be £1.60. So the cost of my pie is going to be 80 pence. And again, I've worked out the cost of the coffee and the cost of the pie. And final one. This is generally how we see them in just a pure algebraic form. So you might say 2x plus y equals 11, 3x plus 2y equals 26. Work out the value of x and work out the value of y so that both of those equations work. Okay? And again, if I draw these 2 pictures, nothing's going to line up because I haven't got the same number of x's and I haven't got the same number of y's. So that's the first thing you have to look at. Do I have the same number of x's or do I have the same number of y's? If you do, you can draw it straight away. If you don't, you have to do something to make you have the same number of x's or the same number of y's. So what I'm going to do is I am going to try and make my y's the same. So what I have to do to this equation is I have to double it. So rather than having an x and a y making 11, I'm going to have 2x plus 2y makes 22. Because I have to double every term, every element. And now I can draw it. Because I've got the same number of y's, that's the letter I'm going to draw first in my diagram. So the first one, I'm going to have 2y's plus 3x's, and that's going to make 26. With my second picture, I've got 2y's, and I've only got 2x's in that one, and that makes 22. So the difference between the two of them is 4. So I can say my x equals 4, because I've only got 1 x extra. And if that's 4 and that's 4, I can say my 2y's here is going to be 22 take away x. So my 2y's are going to be 14. So my y is 7. So the way I'd write my answer is x equals 4, and y equals 7. And that is the answer to solving the two simultaneous equations, x plus y equals 11 and 3x plus 2y equals 26. Okay, have a go at the quiz that is on Google Classrooms and see how you do.